Welcome to the Carbonsations podcast, where we speak to some of the leading figures in the emerging carbon industry. Today, our guest is Dr. Leah Ellis, CEO and founder of Sublime Systems, a startup that is revolutionizing the cement industry with the help of groundbreaking technology, which enables the production of low-carbon cement. Leah, it's a pleasure to meet you, and thank you so much for joining us today. Now, as you know, this podcast tries to focus on the people driving the transition to a net zero economy. So before we discuss what it is that Sublime Systems does, I'm really interested in getting your backstory. What is it that you used to do before Sublime, and how did you wind up in this industry to begin with?
Violet, I'm so happy to be here on this podcast. I am an electrochemist by training. So before I got into cement, I did a PhD in lithium-ion battery chemistry. We were actually working with a group that was sponsored by Tesla, and we were developing cell chemistry. And I've always been drawn to science, and especially to chemistry. I just think it's so magical and so creative. It's a way of changing matter and energy and using matter and energy to create other forms of matter and energy. I just find it so delightful and such a way to solve problems and be creative. And one of the biggest problems that I want to solve with my life and my career is, of course, the climate crisis. And I think, that's the only thing I want to spend my time on. So I always knew that cement was just such a huge lever for carbon reductions. And I remember in my PhD, my material science professor said, everyone working on batteries, you're a 1% improvement in cement CO2 would have a bigger impact than like a 10% improvement in battery performance. And when she said that, that really hit home for me, because I know how hard it is to get a 10% improvement in batteries. And so, I was always attracted to this idea of going to the hardest problems. And I also think that because cement, it's not something that is it gets as interest as lithium-ion batteries, or maybe that's changing. And I think looking for innovations in, forgotten places, I think that's where you can have a real outsized impact. So when I finished my PhD, I came to MIT with Canadian government funding that let me go anywhere, work with anyone, and I chose to work with Yetming Chang at MIT. He's a serial entrepreneur and a prolific inventor, so definitely the type of person I like to work with. And he suggested that we use electrochemistry to decarbonize cement making. And I have to be honest, like, that idea just blew my mind, because electrochemistry is one department in a university, and cement is, often in civil engineering. Those two disciplines don't really cross-pollinate. So that was just such a bold and brassy idea. And of course, it's rooted in all of these industry trends. So we know that, the electricity sector, which is about 30% of global CO2 emissions, that's quickly going to zero thanks to matured technologies like wind, solar, long duration energy storage. And once we have a world that has, abundant renewable electricity, like, where else do we need innovation? And of course, the next biggest levers after the utility sector are cement and steel. And so we just started with that tagline of using electrochemistry to somehow decarbonize cement. And of course, I was coming from Canada, from a school that perhaps nobody had heard of, except if you were a lithium-ion battery scientist. So Dalhousie University in Canada. And I very much wanted to impress this, very prolific and esteemed professor at MIT. So I got busy learning everything I could about cement and trying to basically work backwards from that tagline. And that's what I've been doing ever since then.
Wow, that's fascinating. Thank you for sharing that. Now, I know that you founded Sublime in 2020. Is that correct?
Yeah, March 2020. In fact, Pi Day 2020 to be specific. So both my co-founder and I are a day we all remember, or at least mid-March 2020.
Of course, yes. And that's as we all know, a very, very difficult time in history and for the global economy at large, but specifically for the construction industry as well. How exactly did the idea for Sublime come to you at this point in time, and what was it like to found a company like this at this point in time?
Well, at that point, we had been working on the technology for 2 years at the lab at MIT, and we decided it was time to leave the university and sort of leave the benchtop. So we'd done our proof of concept, got done our techno-economic analysis, we'd done our customer discovery, and we had this thesis. So we had planned to spin out. And at that point when we spun out, we didn't know if the pandemic was going to last a day, a week, a month, or a year. And I don't think and either of us guessed that it would last 2 years. But
I think nobody did.
yeah, it's a wild time. But I'd say it almost made things easier because there's so much to figure out at the beginning, and I had nothing else to do. We all had nothing else to do, so we actually got busy quite quickly.
Okay, and can you share a little bit more about the technology itself and what makes it different?
Yeah, first I'll start by talking about how cement is made today. So today's cement is made in these enormous fossil fueled kilns. The average cement plant produces 1 million tons of cement per year. And 1 ton of Portland cement, that's today's modern cement, releases about 1 ton of CO2 emissions. And about half those emissions are from fossil fuel needed to heat these kilns to 1400 degrees Celsius. And then the other half of the CO2 emissions is from limestone, which is the primary ingredient for cement. So limestone is another word for calcium carbonate. And it is a rock that is 50% by weight CO2. So, the way you make cement is you take this limestone with some other minerals, and you heat it up first to 900 degrees. And at that point, the calcium carbonate decomposes and releases CO2. And then further to 1400 degrees when all these minerals and all that calcium melt and they get kind of sticky and they form a certain crystal that's characteristic of today's Portland cement. Sublime, makes the same hardened concrete that Portland cement makes, and in fact, very similar to what the Romans made, millennia ago. But we go about the process in a different way. So Sublime is much more a process innovation than a material innovation. The way we make cement is we take calcium bearing minerals just like the kiln, but instead of decomposing it with heat and high temperature, which is very difficult to decarbonize efficiently, we break those minerals down with an electrochemical system. So we have an electrolyzer. It's a variation of a water splitting electrolyzer. So one electrode makes acid, the other electrode makes an alkaline solution, and then we use that pH gradient to drive chemistry. So the calcium is extracted using the acid and then precipitated again with that pH swing. And then as a byproduct, we also create silicates. So the mineral we use to get the calcium is not limestone. It's not calcium carbonate. We can use almost anything that contains an appreciable amount of calcium can be an input for us. And so a byproduct of our process is silicates. So our cement is more akin to Roman cement. So we take that reactive calcium, the reactive silicates that come from our process, and we dry them off, blend them together into a free-flowing powder, and then that reacts with water, gels, sets, and hardens the same as you would expect today's Portland cement to do.
Okay, I'm curious, do you or does Sublime Systems have its own factory where you produce cement, or do you work with other cement producers, or do you sell the know-how? How does this work exactly?
Yeah, all of the above. So when we spun out in March 2020, I knew that our focus as a company had to be on scale, because this is the biggest industry by mass in the whole world. We use more cement than any other material besides water. And it's a very, very large and very stoic industry. And, these kilns, they produce 1 million tons a year. It's absolutely gargantuan. So to be real, to be real in the eyes of the industry, to get going on our mission to have a swift and massive impact on carbon emissions, we just have to start crawling up that scale curve. And also it's necessary to produce enough material for customers. So the first thing we did, I'm very proud of, the first 3 years of Sublime. We went from a gram of material produced in a proof of concept cell to a kilogram, and then to 10 kilograms continuously. And now we're operating a 100-ton per year pilot plant in Somerville, very close to MIT. And we've validated the material that we're producing internally and externally, and now it's in the hands of customers. And we expect to announce our first construction projects very soon.
Can you share customer names? Is it okay to?
I can't, but I have to say that our customers are ready-mix concrete producers. So the folks that buy the cement powder, mix it with water, in those rotating trucks. But honestly, there are a lot of people who are our customers, whether direct or indirect, because you own concrete, and everybody owns a little square of concrete. We all pay taxes, and the government, at least in the US, purchases around 50% or more of the cement produced. So there's actually a very long value chain. Cement is, we sell cement to a concrete producer, they sell it to a contractor who, pours and places it, and then ultimately, the money flows up through a general contractor, and then, ultimately to that building owner. So everybody has a say in that cement. Everybody is a stakeholder. So, our direct customer, the cement goes directly from us to a concrete producer, but really everyone in that value chain has power to influence and drive adoption of low carbon products.
Okay. And recently, I know that your product obtained, and I hope I get this right, ASTM C1157 designation, which, as I understand, is an industry standard that enables your product, Sublime Cement, to be used under major US and international building codes. Congratulations on that, by the way. What was the process of meeting the standard like, and what does it mean in layman's terms, if you could possibly describe that? And how is Sublime Cement comparable to regular Portland cement?
Yeah, this 1157 announcement was so exciting for us, and the accumulation of a lot of hard work. But it's funny, it's total industry jargon. It's not only a series of random letters, it's also a series of random numbers. So ASTM is the American Society for Testing and Materials International. And what they do is they, create definitions and test procedures for materials to make sure that they're safe and standardized. So, what ASTM 1157 means, it's the performance-based specification for a hydraulic cement, which means it's defining a cement by its properties. It's a performance-based specification. So for many years, cement was defined by its crystal structure. So the crystals, the crystallographic structure of what is produced in a 1400 degrees Celsius cement kiln. And that is what's made it very difficult to decarbonize cement, because you're solving for that chemistry. Now, recently, this ASTM 1157 has gained prominence. It was created in 1992, and it's very important because it defines cement not by its chemistry, but by its performance. So cement is a material where you add a certain amount of water to the powder, and that mixture will form a gel, and then it'll harden, and then it will, have this compressive strength and that durability, and this is how you measure the durability in all these different ways. And so this standard is very important because that lets you solve for the real problem, which is to create a low carbon material that meets the needs of the construction industry. The problem is not to create a material with a certain crystal structure. That is a very narrow way of solving the problem. So it was a really big deal when our material, passed that standard, because it means now that, we can go in and start to use our material in all all the ways that it's used today. And I have to say, it was a journey. Us as electrochemists coming into this when we were still a very small team, maybe 3 or 4, we'd read a lot of papers about cement. We were like, oh, this is easy. You just mix some lime with some silicates, and then you add some water, and look, these people are getting great results. We can get it too. And oh boy, like were we wrong about that? So our first cement cubes, I can say this now because we're so far away from those days, but they were so they crumbled in our hands like brown sugar. And so we learned a great deal. And honestly, with a lot of help from our customers, where we're like, we want to make this cement. And they're like, okay, well, this is the type of equipment you need to buy. These are how you run the tests. And yeah, it was so encouraging just seeing month by month, quarter by quarter, our cement get stronger, and measuring not only the main properties of strength, set time, flow, but all of the minor properties as well that ASTM requires, and even some of the properties that ASTM doesn't require. And I am just so proud. And we also have, to use upon like just a rock star cement team, where we have folks who've moved their families from overseas, and someone who's come out of retirement from a decades long career in cement to really build this product. And it's something that I'm incredibly proud of launching.
And a probably randomly specific question, but how does one go about measuring the durability of the cement?
That's a great question. So durability, durability is a broad class of things. So there's, freeze thaw resistance, there's alkali sulfate, there's so many different ways that, there's known degradation mechanisms for cement. And then there's specific ways that those are tested. For example, for freeze thaw, we have something that I like to, it looks like a cryogenic coffin, to be honest. It's like, and so we put our concrete cylinders in there, and it freezes and thaws it and freezes it and thaws it. And it can do, 30 winters in an accelerated way. And that's how we measure freeze thaw. And likewise, this durability, because, it actually, you've hit on a very important problem. It is very hard for things like cement, and also things like batteries, which are meant to last for decades. Batteries are batteries are often not meant to last for decades. And I know this from my work on batteries. Before electric vehicles, batteries were meant to last, 3 years maximum. I think there's a lot of planned obsolescence in the cell phone industry. I think we all know about that. So when electric vehicles first came onto the market, and I realize I'm going on a tangent, you'll realize where this is going. But yeah, when electric vehicles first came on the market, it was, Tesla wanted to know what sort of warranty they could put on their battery, because no one had ever really pushed the lifetime limits of batteries. So, part of my work in my PhD was developing these accelerated tests. So how can you test a battery very quickly, and within a couple months predict with very good accuracy how long it will last and in what conditions? And so it's the same thing with cement. You can do these accelerated tests that are very well known, and ASTM and all those committees are involved in creating and refining these test methods. It's basically very harsh accelerated tests, like soaking the concrete in really aggressive sulfate solutions, and then watching how that cement expands. You can predict how it would crack over time in a much milder situation. Sorry, I'm a chemist, so I did take a deep dive there.
Oh, no. That was my intention, actually. I'm really fascinated by the details of what you do, and thank you for the insight. But on a broader level, let's say, how do you see low carbon or even carbon negative cement scaling and becoming more popular?
I think it's going to, the industry is changing very, very quickly. I think even those who've been in the industry for decades have told me, Leah, I have never seen the industry respond so quickly. And I think it's not only important morally, I think it's a good business choice. We have to de-risk our supply chains. We have to find other products because, 2050 is less than 30 years away. So, everybody's moving to decarbonize. And I think everybody's moving to decarbonize in general, as you know, and why I think cement is a very interesting way of decarbonizing is because it is a very inexpensive product. Cement today, because it's made at such massive scale, costs about $130 a ton in the US. And these new technologies like Sublime and also post-combustion carbon capture, that tacks on a lot of cost onto making cement. So not only do you have to have this very large kiln, you also have to have this very large carbon capture plant that's always going to double the cost of cement making. And Sublime's technology, we think that we can compete on cost with today's cement that's made in kilns, no carrots, no sticks, when we are at scale. And that's because what we're doing is we're not adding on to that cement plant. We're not adding a different unit or, more unit operations. What we're doing is replacing that system with another system. So, the limit how cheap our technology could get is within range of the selling price of today's Portland cement. However, right now, because we're making it at such small scale, I like to joke that we've got a cement plant for ants because it's small. Yeah, I know it has to be, at least 3 times bigger than this. But because it's small, we have.
Sorry, it has to be 3 times bigger to what?
Oh, that was just a joke from Zoolander. Maybe so.
Oh.
Understand. It has to be much more than 3 times larger. So, today we're at 100 tons a year, but really we have to get to 1 million tons per year. And when you're making cement at such a small scale, it's going to have, it's going to be a boutique product with a premium. And that would be true even if you took Portland cement and made it, at this ant-sized scale. But the exciting thing is that, even if we charge a 2x green premium, or even let's say a 3x green premium on low carbon cement, the dollars you are spending per ton of carbon you avoid is still very low, especially when you compare this to other clean technologies like direct air carbon capture or like sustainable aviation fuel. It actually, if you're talking about a large company like Amazon or Google or, if they want to lower their scope 3 carbon emissions and they want to do so in the cheapest way possible, I think low carbon cement is in fact an obvious choice for them. And that's why I think it's going to be one of the most important levers as we go forward.
Circling back to the 100 million tons per year that you mentioned, is this the scale necessary to bring the cost down to make it comparable to like regular cement? Or what exactly is this scale needed for?
Yeah, that's right. It is to bring the cost down, but it's also, the scale needed to produce the volume that the market demands. So cement plants have gotten so big and cement has therefore gotten so expensive simply because you have to produce so much of it.
Is this for the US only? Sorry.
Yeah, so the US consumes about 100 million tons of cement per year. But globally, it's about 4 billion tons of cement per year. So, yeah, it's a massive industry.
Have you considered expanding like beyond the US?
Totally. So our Sublime's mission is to have a swift and massive impact on CO2 emissions. That is the only thing I care about. If I'm being honest, I hope my investors aren't listening. I mean, I do expect to run a profitable company, but in my opinion, like that is a byproduct of success. And we measure our success in the amount of low carbon cement we produce and sell integrated over time. And I think, you could do that in the States, but really most of the cement that will be produced and most of the cement plants that will be built before 2050 are going to be in developing countries such as India and regions such as Africa. So, if we want to achieve this mission of decarbonizing cement, we're going to have to go and deploy this all over the world as quickly as possible, especially in developing countries who are going to be building the most. And so, our first, we have to build this technology close to home. We're a US-based group, and so we're building this first commercial plant in Massachusetts. But once that first commercial plant is up and running and we've validated not only the product but also the process, we will be looking to deploy this internationally, and ideally with help from the incumbent cement majors. I think we recognize that as a startup, what we understand and do really well is electrochemistry, material science, building this first of a kind electrochemical system. But we can't have that swift and massive carbon impact, or, we can't do it as quickly and as massively alone. I think, the cement industry, although it is old and perhaps not innovative, they are experts in what they do, and they do it very, very well. So mining, crushing, grinding, logistics, transportation, all of, transporting massive amounts of material on time and on spec. These are, for me as an innovator and a chemist, like, these are not the things that get me out of bed in the morning, but we have to partner with people who do get out of bed in the morning with a drive to do those things. And that's how I think we'll succeed in this mission together.
So my last question for you before we finish up. So these are obviously Sublime's plans for the more distant future, let's say. But what are your next steps? Like, moving on from here, what's next for Sublime?
Yeah, what's next for Sublime is the next level of scale. So today we are operating this pilot plant. We finished building it just after Christmas. It's done almost 1,000 hours of uptime. It's produced tons of cement. And so now that we've optimized it, we have the data and the plans for our next scale up. So this is somewhere between where we are now at 100 tons a year and where we need to be at 1 million tons a year. Obviously, a 1 million ton per year cement plant is an enormous, it's enormously costly. Even today's cement plants are hundreds of millions of dollars. And so before we go straight to full scale, we have to build this mid-sized first commercial plant, which is large enough to be commercially relevant and industrially relevant, but isn't yet at the scale where you can compete on cost. So that is our next step. And I hope your listeners will follow Sublime's progress, because we expect to be announcing some interesting news over the coming months and years about the build out of that plant.
Oh, certainly. And we certainly hope to have you as a guest again on this podcast. Leah, thank you so much for taking the time to have this conversation. It was a genuine pleasure to have you here as a guest. And I really appreciate the insight you shared with us today. Thank you again.
Thanks, Violet.
If you enjoyed this episode of the Carbonsations podcast and would like to hear more conversations like this, please be sure to subscribe. We really appreciate the support.